We present EMO4SD, a classifier for emotion recognition from textual analysis of communication artifacts shared by developers on social software engineering tools. The envisioned users of our tool are both researchers and practitioners interested in investigating the role of emotion in software development. EMO4SD can be used for emotion detection from technical text contributed by developers during the interaction on collaborative development platforms. Software development is a social activity involving a large amount of interaction as programmers often need to cooperate with others. Recent research has provided evidence that software developers shared and experienced a wide range of emotion and express them throughout the rich ecosystem of communication channels such as Slack or Stack Overflow. One of the biggest drawbacks of communication through social media is to appropriately convey sentiment through text. While display rules for emotions exist and are widely accepted for interaction in traditional face-to-face communication, web users are not necessarily prepared for effectively dealing with the social media barriers to nonverbal communication. Thus, the design of systems and mechanisms for the development of emotional awareness between communicators is an important technical and social challenge for research related to computer-supported cooperative work and social computing. Recent research has provided evidence that software developers experience a wide range of emotion and express them throughout the rich ecosystem of communication channels. As such, a recent trend has emerged to study the role of affective states in software engineering by mining crowd-generated content within social software engineering tools. Furthermore, the dedicated workshop series C-Motion was started in 2016 at ICSE, specifically addressing emotion awareness in software engineering. What most of these studies have in common is that they applied sentiment analysis techniques to crowd-generated content, relying only on polarity, that is, the positive, negative, and neutral tone conveyed by the text, as the only dimension to operationalize the affect. However, polarity detection is only one of the possible dimensions of affect analysis, and previous research advocates in favor of the emergence of sentiment analysis tools monitoring communication between developers at a more fine-grained level, by detecting specific affective states such as love, or gratitude, or sadness, or anger, as well as their target, whether I am referring to a tool, a teammate, so as to enable translation of emotion mining into actionable insights. So despite the increasing attention for sentiment analysis in software engineering, tools for automatic detection of discrete emotions such as anger, joy, or surprise from technical text have been so far unavailable. So in this contribution, we fill this gap by releasing EMO4SD, which is, to the best of our knowledge, the first publicly available emotion classifier specifically trained to detect emotion from the textual analysis of developer communication artifacts. EMO4SD is trained using two gold standard datasets collected from the software engineering domain and manually annotated with emotion labels. The first dataset is a gold standard from Stack Overflow posts, which includes answers, comments, and questions. And it was manually annotated with the 6 basic emotions from the Shower framework. The same framework is adopted in the second dataset, which includes 4,000 sentences from the Apache issue tracking system. The Shower framework is organized as a tree-structured hierarchical classification of emotions, where each level refines the granularity of the previous one, providing more indication about the nature of the emotion itself. At the top level, we have the 6 basic emotions which we use in our classification model. EMO4SD is distributed under open source license, and along with the tool, we release the classification models we trained and evaluated on our datasets. It is trained in supervised machine learning setting using support vector machine. In addition to uni and bigrams, we exploit a suite of lexical features to capture the presence of lexical cues of emotion in the text. Specifically, we use the emotion lexicon modeled by word-net affect, and we compute TF-IDF for each emotion category based on the occurrences of words associated with those categories in word-net affect. Then we measure politeness conveyed by the text, its positive and negative orientation, and the level of uncertainty as conveyed by grammatical moods and adverbs. Before proceeding to feature extraction, texts are tokenized using the Stanford NLP library, and also HTML tags, code fragments, and URL are removed because they might introduce noise in the training and classification stage. The classification models used by Emo4SD are specifically trained on the technical domain and are fully available to researchers for classification purposes. To use Emo4SD, the input text should be provided as a CSV file. Every line is a text unit which we want to analyze in order to detect emotion, and it is preceded by a unique identifier. Emo4SD is structured as a suite of 6 binary classifiers which predict the presence or absence of each emotion in the input text. This choice is consistent with the annotation guidelines adopted for our gold standard that allow multiple emotion labels for the same text unit. To start the analysis, user needs to specify the name of the input file, the delimiter, and the emotion we are looking for in the text, which is sadness, for example, in this example. The default models are used by the classifier and are those that we release with the tools trained on our gold standard sets. However, custom model can be trained by users based on manually annotated gold standard provided as input, as Emo4SD is trained using an open source toolkit that we developed and distribute for general purpose emotion classification models. In that case, if users retrain their classification model, this can be specified as input for the classify method. Finally, the output of the analysis is another CSV file containing the ID and the predicted label for each item of the input set.